Welcome to this lecture. In this lecture, we shall study about the length of an arc of a curve. Now here, let's consider this figure and let's assume that this is a graph of a function which is given by y is equal to f of x, or then later on we shall convert the given function into parametric form, or we may also be given the function in the polar form, or we can convert a given function into polar form, but the graph will always remain the same. Now here in this graph we shall try to see what we mean actually by the arc length. Suppose on the x-axis we plot some points, like suppose this is a point A, and suppose this is a point B. Here we have a point C, here we have a point D, and so on, and this is the origin. Now on this curve, if we mark this point A on the curve, so we will have this is the point A with some y coordinates. Suppose let's call that y of A, and similarly on here we will have a point, suppose x is B, and let's call its y coordinate as yb, and similarly here we may have the C with coordinate cyc, and similarly here the point D with coordinate as d comma yd. Then by finding the arc length from suppose A to B, we mean to find the distance from this point A comma ya to point B comma yb. So therefore this distance is actually the arc length from A to B on this curve. And similarly, the arc length from B to C, it is the distance like this. This is what we actually mean by the arc length. Now here in this lecture, our plan is to evaluate the arc length of a curve between two points when the curve is given in Cartesian form, or parametric form, or polar form. Okay, so first of all, we take when the curve is given in Cartesian form. अब अगर हमारी कर्व कार्टेशियन फॉर्म में होगी, फिर भी यहाँ पे दो तरह की कार्टेशियन फॉर्म्स हो सकती है. सो पहला केस हम लेंगे सपोज 1.1, जहाँ पे कर्व हमारी होगी y इज इक्वल टू f of x, या दूसरा केस हो सकता है when the curve is given in this form x is equal to some g of y. Now here in this case, arc length is denoted by s, and this is defined as square root of 1 plus derivative of y with respect to x whole square. Then we take the integral of this function between the points a to b with respect to x. And similarly, the arc length in this case, which is again denoted by s, and now here in this case, this is defined as integral of 1 plus dx by dy whole square. Then we take the square root here, integrate this between the points a and b with respect to y. तो इस तरह से हम हर arc length को define करते हैं when our curve is given in Cartesian form. Our notation for the arc length is always s, so we shall mention this notation here. S denotes the arc length. तो अगर हमारी कर्व होगी y इक्वल f of x, तो हम arc length इस तरह से डिफाइन करते हैं. अगर कर्व होगी x इक्वल g of y, तो हम arc length डिफाइन करते हैं इंटीग्रल a to b 1 plus dx by dy whole square. या इसको कभी हम ऐसे भी लिख सकते हैं, the first one is integral from a to b square root of 1 plus y dash whole square with respect to x. और इसी तरह से हम ये वाला ऐसे लिख सकते हैं, this integral from a to b 1 plus x dash whole square square root between them with respect to infinity to y. Now similarly, when we take the second form, when the curve is in parametric form, तो इस केस में our given curve will be of this form, x is equal to x of t, y is equal to y of t. तो इस केस में then arc length is given by, again it is denoted by s, and this is defined as integral between the points suppose a to b, then square root of dx by dt whole square plus dy by dt whole square. Then we integrate this expression with respect to t. So this is how we define the arc length when the curve is in parametric form. इसी तरह से third form हमारी हो सकती है when the curve is in polar form. Say our curve is given by r is equal to f of theta. Then the arc length is given by, again it is denoted by s, and now in this case it is defined as square root of r square plus dr by d theta whole square. Now here we can integrate between the 2 points, suppose theta 1 to theta 2 with respect to theta. So these are three different ways of evaluating the arc length of a curve whenever curve has a given type of a representation, either in Cartesian form or parametric form or polar form. एक्सरसाइज लेने से पहले हम यहाँ पे थोड़ा सा और भी यहाँ पे लिख लेते हैं. कभी कभी क्वेश्चन जो हमें एग्जाम में आते हैं वो कभी इस तरह से आते हैं. सो सपोज दिस इज वन रिमार्क टू नोट हियर. अगर हमें इस तरह से होगा, इफ y is equal to f of x, then we define this derivative of arc length with respect to suppose x. This is defined as square root of 1 plus dy by dx whole square. And similarly, if x is equal to f of y, then derivative of arc length s with respect to y, now here in this case this is defined as 1 plus dx by dy whole square. And we can have a curve if x is equal to x of t and y is equal to y of t, then the derivative of arc length is given as, then this ds by dt. This is defined as square root of dx by dt whole square plus dy by dt whole square. And lastly, if we have the function r is equal to f of theta, then this ds by d theta अगर हम लिखेंगे, this is defined as square root of r square plus dr by d theta whole square. और similar lines, और हम ऐसे भी डिफाइन कर सकते हैं ds by dr. अगर हम डिफाइन करेंगे इस केस में तो ये डिफाइन किया जाता है, this is equal to 1 plus r square d theta by dr whole square. So these are certain formulas that we need to remember when we are studying the arc length of the curve. तो एक्चुअली जो हमने यहाँ पे रिमार्क में पहला लिखा है y equal to f of x, then ds by dx is equal to square root of 1 plus dy by dx whole square. अगर इसी एक्सप्रेशन का हम इंटीग्रेशन करेंगे ऑन बोथ साइड्स, then we will get s is equal to integral a to b square root of 1 plus dy by dx whole square, जो हमने ऊपर पहला फार्मूला लिखा है to find the arc length between of a curve y equal to f of x in Cartesian form. And similarly, इसी तरह से अगर हम बाकी यहाँ पे रिमार्क में एक्सप्रेशंस का इंटीग्रेशन करेंगे बोथ साइड्स बिटवीन द पॉइंट्स a to b, और जो भी पॉइंट्स हमें कर्व पे दिए होंगे, then we will get arc length in each case. Now let's take up some exercise. So in the solution, now here you can see the curve is given in Cartesian form. So given y is equal to 4 minus x square. The arc length is given by s, which is equal to, here in this case, integral from 0 to 1 square root of 1 plus dy by dx whole square. And here we have to integrate with respect to x. Now let's evaluate what is our dy by dx. So now dy by dx, as we can see from above, it is equal to minus 2x. Hence this dy by dx whole square, this is equal to 4x square. तो अब हमें इंटीग्रेशन करना है. So therefore this s is equal to integral from 0 to 1 square root of 1 plus 4x square with respect to x. तो ये जस्ट हम यहाँ पे एक्सप्रेशन में सब्स्टिट्यूट कर दिया dy by dx का वैल्यू. Now this can be expressed as integral from 0 to 1, this is square root of 1 plus 2x whole square. तो अब यहाँ पे जो हमारा इंटीग्रल है, we have इंटीग्रल ऑफ द फॉर्म a square plus x square. तो जो यहाँ पे हम मेंशन करके रखेंगे, इंटीग्रल फ्रॉम इंटीग्रल ऑफ a square plus x square dx, दिस इज इक्वल टू, तो इस तरह से हम इस इंटीग्रल को डिफाइन करते हैं. नाउ हियर इन दिस केस, सो देयरफॉर वी कैन, दिस इज इक्वल टू, अब यहाँ पे x की जगह पे है 2x, सो वी कैन राइट दिस इज इक्वल टू 2x डिवाइडेड बाय 2. नाउ स्क्वायर रूट ऑफ 1 प्लस 2x होल स्क्वायर, दैट इज इक्वल टू 1 प्लस 4x स्क्वायर, देन प्लस a स्क्वायर बाय 2. अब e की जगह पे यहाँ पे 1 है, सो वी कैन राइट 1 डिवाइडेड बाय 2, देन log ऑफ, तो x हमें लिखना है लेकिन यहाँ पे x की जगह पे 2x है, देन 2x प्लस स्क्वायर रूट ऑफ द सेम 1 प्लस 4x स्क्वायर. बट यहाँ पे अब 2x था तो हमें इस पूरे एक्सप्रेशन को डिवाइड करना होगा 2 से, So this is multiply 1 by 2, and we have to integrate this expression from 0 to 1. So this is equal to 1 divided by 2. Now first let's substitute 1 everywhere for x. We get 1 into square root of 1 plus 4. So that is equal to square root of 5. Then plus 1 divided by 2. Then log of, अब यहाँ पे x की जगह पे फिर से x 1 लिखना है, so we get 2 plus square root of 5. Then minus, when we substitute 0 in the first expression we get 0, and similarly when we put x in the second expression we get 0, so this is minus 0. So therefore our final answer is square root of 5 divided by 2 plus 1 divided by 4 log of 2 plus square root of 5. So this is the arc length of our curve between the points 0 to 1. Now let's take up example number 2. Find the length of the cardioid. The equation of the cardioid, as we already know, is given by r is equal to a into 1 plus cos theta. तो हमें जस्ट दिया है फाइंड द लेंथ ऑफ कॉर्डियोड, और इसका मतलब ये है कि हमें पूरे कॉर्डियोड की लेंथ फाइंड करनी है. Now we must be knowing here that the length of the cardioid is actually given from 0 to pi. So हमें actually integration करनी है from 0 to pi. So now let's take a solution. Here our curve is in, here the given curve is in polar form. Therefore we use the similar formula for find the arc length. So the arc length is given by, this is given by s is equal to integral from 0 to pi, then square root of r square plus dr by d theta whole square. तो इसका हमें इंटीग्रेशन करना है with respect to theta, and theta here varies from 0 to pi. So actually total length of the cardioid is obtained from by evaluating the expression from 0 to pi. So now let's find what is our dr by d theta. Now r is equal to a into 1 plus cos theta. Therefore this dr by d theta, this is equal to minus a sin theta. So that is, we can find the value of dr by d theta whole square. Then this is equal to a square sin square theta. तो इस तरह से हम ये फॉर्मूलाज अब यहाँ पे सब्स्टिट्यूट कर सकते हैं. Therefore, so hence पहले हम सब्स्टिट्यूट इवैल्यूएट करेंगे व्हाट इज दिस r square plus dr by d theta whole square, ताकि हमें इंटीग्रेशन करने में आसानी हो जाए. Now as we know r is equal to a into 1 plus cos theta, so this becomes a square into 1 plus cos theta whole square, then plus dr by d theta whole square जो हमने ऊपर इवैल्यूएट किया, this is equal to a square sin square theta. Now this becomes a square, अब इसका स्क्वायर हम एक्सपेंड करेंगे, this is equal to 1 plus 2 cos theta plus cos square theta. अगर कर सकते हैं, this is equal to a square plus 2 a square cos theta plus a square cos square theta, then plus a square sin square. Now again simplifying this, this becomes a square plus 2 a square cos theta. अब इन दो को हम कंबाइन कर सकते हैं, we can take a square common, so this becomes a square into cos square theta plus sin square. Now this becomes a square plus 2a square cos theta, then again plus a square, because this expression is equal to 1. So finally this becomes 2a square plus 2a square cos theta. अब इसको हम रिप्रेजेंट कर सकते हैं, this is equal to 2a square into 1 plus cos theta. लेकिन अब इसको हम थोड़ा सा और भी सिंप्लीफाई कर सकते हैं, this is equal to 2a square, अब 1 plus cos theta को हम लिख सकते हैं twice cos square theta by 2, twice cos square theta by 2. इससे हमें इंटीग्रेशन करना थोड़ा सा आसान हो जाएगा. और यहाँ पे हमने फॉर्मूला यूज किया है cos 2x is equal to 1 minus twice cos square x. तो इससे हमें आएगा वैल्यू this therefore this cos square x, we can write this as 1 plus cos 2x divided by 2. तो इस तरह से हम ले सकते हैं, this is equal to 1 plus cos 2x is equal to twice cos square x. लेकिन अब जो हमारा यहाँ पे क्वेश्चन है वी आर जस्ट 1 प्लस कॉस थीटा, तो इस हिसाब से अगर हम x 2x की जगह पे थीटा रखेंगे, सो दिस इम्प्लाइज 1 प्लस कॉस थीटा जो होगा दिस इज इक्वल टू ट्वाइस कॉस स्क्वायर थीटा बाई 2। तो ये फॉर्मूला हमने यहाँ पे यूज किया है to simplify this expression. Now finally this expression becomes 4a square cos square theta by 2. So now finally we are ready to integrate our to find the arc length. So hence the arc length s is which is given as integral from 0 to pi square root of r square plus dr by d theta whole square. d theta this is equal to integral from 0 to pi. अब हमने ऊपर इवेल्युएट किया है r square plus dr by d theta whole square. This is equal to 4a square cos square theta by 2. इसका स्क्वायर रूट में करना है d theta. So we can write this as integral from 0 to pi. अब इस अंदर वाली एक्सप्रेशन को हम ऐसे लिख सकते हैं दिस इज इक्वल टू 2a cos theta by 2 whole square. Then we also have a square root here d theta. Now here we can cancel the square and the root, so this is equal to integral from 0 to pi 2a cos theta by 2 d theta. Now we can take this 2a outside and integral from 0 to pi cos theta by 2 d theta. Now cos का इंटीग्रेशन हम जानते हैं that is equal to sin theta, so this is equal to 2a. Now cos theta is integral sin theta by 2, और इसको डिवाइड करना है कोफिशिएंट ऑफ थीटा which is 1 divided by 2 and its integral varies from 0 to pi. So finally this becomes 4a sin theta by 2 and integral varies from 0 to pi, so this is equal to 4a. Now when theta is equal to pi, so we get this is equal to sin pi by 2 minus sin 0. Therefore this is finally equal to 4a because sin pi by 2 is equal to 1. Now we shall add these limits here in the question. This is from 0 to pi. Now here we add one note here. The total length of the cardioid is equal to twice integral from 0 to pi then square root of r square dr by d theta whole square with respect to theta. And we have already evaluated this limit, so therefore this must be equal to 4a, and equation of the cardioid is already given in the above example. यहाँ पे हम cardioid की शेप भी बनाने की कोशिश करेंगे so that we can properly understand cardioid की हम लेंथ कैसे डिफाइन कर सकते हैं. Suppose this is our xy plane, तो जो हमने ऊपर cardioid लिखा था it was r is equal to a into 1 plus cos theta. कॉर्डियोड की हमने इस तरह की इक्वेशन लिखी थी, तो इसका ग्राफ कुछ इस तरह से बन जाता है. इट स्टार्ट्स फ्रॉम हियर एट 0, तो फिर थोड़ा सा इस तरह से बनेगा. सो दिस इज द इट्स नॉट एक्चुअली अ सर्कल, सो दिस इज द कॉर्डियोड. सो दिस इज द कॉर्डियोड r इज इक्वल टू a into 1 plus cos थीटा. इसी तरह से अगर हम एक और शेप यहाँ पे कंस्ट्रक्ट कर देंगे एंड वी विल कंस्ट्रक्ट इट लाइक दिस, तो जो ये वाला cardioid है its equation is actually r is equal to a into 1 minus cos theta. So now when we have evaluated the length of the arc of cardioid, so it is from 0 and this is pi, and similarly यहाँ पे ये होगा 0 and this is minus pi. तो अगर हमें अब cardioid की length फाइंड करनी है which is suppose equation is r equal to e into 1 minus cos theta, तो हम इस का इंटीग्रेशन कर सकते हैं from minus pi to 0. तो माइनस पाई टू 0 या 0 टू पाई की लेंथ एग्जैक्टली सेम होगी. सो यहाँ पे हमने किया 0 टू पाई, सो इट हैज एक्चुअली गिवन अस द लेंथ ऑफ दिस अपर हाफ प्लेन ऑफ द cardioid. लेकिन नीचे भी एग्जैक्टली इसका सिमेट्रिक शेप है, तो इस तरह से हमने इसको यहाँ पे फॉर्मूला में आप डबल कर दिया. या अगर हमें cardioid होगा a into 1 minus cos theta, तो जब हम इवेल्युएट करेंगे करो फ्रॉम माइनस पाई टू 0, तो हमें इस तरह से ये मिल सकता है. सपोज द अपर हाफ प्लेन माइनस पाई टू 0, फिर उसको भी डबल करके हमें एग्जैक्ट यही आंसर मिल जाएगा, एक्चुअली 8, इट इज 8. तो हाफ लेंथ ऑफ द cardioid is 4a and the full length of the cardioid is 8.